So today we'll be learning about experimental probability. Don't be too scared. It's actually quite a nice chapter that is very easy to follow. Um, and this is chapter 8K. But before I take you through the the unit, let's just do a starter activity based off what we previously learned in chapter 8J, which is about Venn diagrams and two-way tables. So in your whenever you do your questions, you'll be given a context. They'll give you some nice information, then they'll just ask you like to do some of the following. So for example, drawing a Venn diagram, drawing a two-way table, or they'll ask you to find the probability of the events pretty much. So do not stress too much. Let me just charge my laptop. There we go. So your class surveyed 20 students about two interests. Um, One of them is like, hey, they own a pet, and the other interest is, hey, they play a sport. Now, this section here is pretty much important because that gives you the information you need to sort of like answer your questions, okay? So in this case, 9 students own a pet, 12 students play a sport, and 6 students not do, but I'll just say have both. Okay. But you sort of get the idea. They have an interest in both. Okay. Interest in both. So number one, draw a Venn diagram. So let's just go over here. Let's just make sure we draw a Venn diagram. Make sure we do it right. Just remember, start off by drawing your two circles, draw a box around it. Um, and then just add in the funny symbol. And that is pretty much how your Venn diagram should always start looking. Okay. Now, in one circle, what we're going to do is we're just going to label it as sport, and then the other one is going to be pet. Now, it doesn't matter which one you do, sport or pet, as long as you label one of the circles as the following. Now, based on the information provided, um, the one to start out with is always the one where they provide you with both. So, 6 students have an interest in both. So, what you're going to do is in the middle, so at the section where the two circles are overlapping each other, you're going to write the number 6, okay? So 6 students satisfy both interests. Now, the next thing you need to watch out for are these two. These two, you got to be careful, okay? Because, say, for example, if I select 9 students owning a pet, if you have a look in my Venn diagram so far, I've already taken into account 6 of the students already. So what you're not going to do, you're not going to write 9 here. This is completely wrong. Okay, don't do that. Remember the whole circle must add up to 9. So since I've already accounted for 6 people already, I just need to fill in the missing amount, which is 3. And then like just to double check that you've done it right, you can just add these two numbers and make sure they are what we want in this question. In this case, it is 9. So since we're done with the pets, we can now move on to sport. So we have 12 students here that have an interest in sport. Now, in my Venn diagram, I've already taken into account 6 of them already. So I must find the remaining amount that also make up 12. So in this case, it's 6 as well. Now, in this case, this circle just technically means they have a pet only. And in the sports circle, this is just sport only. So they don't have an interest. So pet only just means, hey, they're interested in pets, but they're not really interested in sport. And the other circle in this case is they're interested in sport, but they have no interest in pets. Now, the question here mentions that we have 20 students. Now, let's just count up how many students we've got so far in our Venn diagram. So first we have 3 plus 6 plus 6, and that equals to 15 students. But the thing is, we need 20. So that means you can just like make a deduction saying, hey, 5 of them have no interest in pets, and they have no interest in sport as well. So that's where you get the five from. Okay. Uh, Question two: how many students have a pet or are interested in pets or they're interested in sports in this case? What you're gonna do is you're just gonna add up the numbers, which I've already done already. It's technically 15 students because the key word here or just means uh you can pick pet only, you can pick both, or you could pick sport only. And what you're going to do is you're just going to add up the numbers, which I have just done already for you, which is just 15 students. And that's pretty easy. Now, question three says create a two-way table showing based off the information above. So, to create a two-way table, put things that you need to start out, okay? You're first going to have one category here. So, category, and then another category on the side. And then you're just going to split it up like this. So, category one. I really wouldn't say category. Oh yeah, you can technically say the category, but just to make it a bit easier, I'm just gonna set it up like this, okay? So first off, it doesn't matter what I put first. I'm just gonna put in this case pet first, and then no pet. Just make sure you have the no part. The no part is very important, or like no interest in pets, because it's to show that not every single person like pets. Okay, there's also people that don't have an interest in pets. And then on the other side here, in this section, I'm gonna write sport and then no sport. Now, this is the basis of setting up your table so far. Total. Let's just finish filling it out just to make our lives a bit easier. Great, just like this. Now, you can use the information from the Venn diagram and just transfer it directly over, or you could just go based off this. But because we already have the Venn diagram, it's actually easier to do it that way. Now, what you're gonna do is you're gonna pretty much draw like invisible lines, and you're gonna look at the intersection. Okay, the intersection is like think about it like this: how many people like pets, or like how many people have interest in sport and keyword and pets. So just going based off my little invisible black lines, my dotted black lines so far. And then you just look at your Venn diagram, just be like, hey, what does that mean in my Venn diagram? That's technically the middle section. So what you're going to do is you're just going to write six people satisfy that condition. And then you're just going to do the same with the no sports section. It's like, hey, how many people like have an interest in pets, but they don't really have an interest in sport? So in our Venn diagram, that is three. Now, the next step is quite straightforward. If you go down this column there, what you're going to do is just add it up. So if you add up the numbers, so if you plus the numbers together, what you get is 9 in this total here. And if you just double check your information, it says here 9 students own a pet. And just based off that column alone, I've done it right so far. And then you just pretty much continue to progress on with your little invisible lines and just fill out the rest of the table. Okay. Oh, come on. Right. Just like that. How many people like sport, but they don't like pets? In your Venn diagram, and that's 6. So that should add up to 12. And then how many people don't like pets and they don't like sport? That's 5. And then you just keep adding up your numbers. and it should add up to 20. Now, the reason why it should add up to 20 is because we investigated 20 students, okay? Just like that. Question 4 here. Let's just go through it. Find the probability that a randomly selected person owns a pet. I'll just say interest, okay? So, so part A, PR, pets. So pets in general, there's actually 12 out of the 20 people. And then if you can simplify the fraction, please do so. So this will be 3/5. And then what was part B? Part B was sport. Sport is pretty much. Wait a minute. I looked at this wrong. Pets should be 9 out of 20. It's the sport that should be 12 out of 20. And then that becomes 3/5. Part C is pet and sport. So PR, pet and sport. And that will be 6 out of 20. And then that could be re simplified as 3/10. And then finally, it's just neither, P, PR neither equals 5 out of 20, which equals to 1/4. I'm sorry if it's a bit smushed, but yeah, there we go. So let's just move on with experimental probability. So the learning aim of this video is that we'll be understanding the difference between theoretical and experimental probability. And number two is we'll be calculating the probabilities based off the experimental results. So pretty much the results that you earn or you achieve. Okay, let's just start out. What is experimental probability? It's just what you get. Okay, so you conduct the experiment yourself. So let's just say you flip a coin, you're gonna like record all your results. That's all you. Nothing is predictable. Now, the formula that you use is this one right here. Please write this formula down. Very important. Now, one great thing about this formula is that it is very similar to the formula that I showed you in chapter 8G. It's very similar, but the only difference is that this is technically for your experiment, whereas the one in 8G that I taught earlier is more about theoretical. So it's like more idealistic, pretty much. Now, the next thing is the expected number of occurrences. This is just an estimate of how many times you expect something to happen. Okay. It is not guaranteed. It's just something that you sort of expect. Like you're pretty much like guesstimating. Now, whether that actually happens or not, who knows? We don't really know yet. Okay. Now, this is the formula here. Expected number of occurrences equals the probability times the number of trials. Say, for example, if I flip a coin, okay, and let's just say I want heads, and then I flip it, let's just say 600 times. Yeah. So it's like, how many times would you expect heads to show up? So if you just apply your formula, it's just 1/2 times 600, which equals to 300 times. Okay. That's just the formula as it is. Very straightforward. Now, let's just go into an actual example here. Red, white, and orange marbles are placed in a jar. Repeatedly, a marble is taken out, the color is recorded, and the marble is replaced in the jar. Now, the word replace here just means I can put it back. Can put it back. Now, when that happens, the total amount of marbles doesn't change, which is pretty cool. And it makes life a bit easier for us. Like calculating the probability, so much better and a lot less thinking involved. Now, results are tallied on this table. So I'm just looking at the table here. I'm just going to count out how many each marble appeared. Okay. So this will be 8. This is 12. This is 10. Now, part A says, what is the experimental probability of a red marble? being chosen next. So just based off our results, we are just going to apply this formula right here. PR event, number of times event occurs over the total number of trials. So far, we've actually tallied a total of 30, 30 experiments. So PR of red equals to 8 over 30. And then if you can simplify, then great, do it. So in this case, the simplifying is by 2. So this just turns out to be 4 out of 15. That is the probability of me drawing a red marble on the next draw. Part B. What is the experimental probability of a red or white? Okay, red or white. So let's just remember these were the numbers that I had. So the chances of me drawing a red or white, what I'm going to do is I'm actually going to add these two numbers together and put it over the total amount of trials that we've done so far. So 8 plus 12 is 20 over 30. And then if you can simplify it, then you will. So that means the probability of me drawing either a red or white marble on the next draw is 2/3, which is actually pretty high. That's very, very high. Now, finally, if the experiment was done 600 times, what is the expected number of times that an orange is selected? Okay, so let's just go based off what we got here. So let me just rewrite the amount of marbles. What's our formula? Here we go. So expected number of times that an orange to be drawn is the probability times the number of trials. So I need to first find the probability of orange. So the probability of me drawing an orange one on the next draw is actually 10 over 30, which actually equals to 1/3 if you simplified it. So the number of times orange is just going to be 1 over 3 times 600. And then if you figure that out, it just ends up being 200 times. So expect orange to show up 200 times. That's all it is. And that is the very essence of experimental probability. Now, the slides will be up so you can just have a look here. You can try and work this out. And then, yeah, once you're done with that, you can just start working on the questions. Okay. Now, do remember your project does start next week. It is technically 3 whole periods. I personally think that you will enjoy this quite a lot, so you should be a okay. But yeah, take care. Enjoy the rest of your day.